Okay, so before we get into question one, just a word about our inverse theorem, our inverse function theorem. So we're going to let f of x be our original function, and I like to call the inverse h as opposed to using this notation. I think it's just a little bit neater. So then we would know that using our inverse function theorem, the derivative of that inverse is equal to 1 divided by the derivative of f of h of x. So to solve this first problem, it's asking us to look at the original function f of x equals x cubed plus 4, and we're going to let h of x be equivalent to its inverse. And the problem wants us to evaluate the inverse at 220, the derivative of the inverse at 220. So if we plug this into our inverse function theorem right here, you can see that we need to know what h of 220 is equal to. Well, we know that h and f are inverses of one another. And since they are inverses, the input of one becomes the output of the other, and vice versa. So we need to determine what h of 220 is. So to do that, we're going to set x cubed plus 4 equal to 220 and solve the equation. So we have x cubed plus 4 equal to 220. So when we solve that using our algebraic properties, we get that x is equal to 6. So at this point, we are now ready to use our formula here, but we know that h of 220 is equal to 6. So you're going to need to determine the derivative of x cubed plus 4, which I'll go ahead and let you do that piece. So you're going to derive x cubed plus 4, and you're going to evaluate it when x is 6. And then you're going to take that and you're going to divide 1 divided by that value, whatever that value is that you get. But the key to this problem here was really recognizing that, okay, we are looking for